everyone, it's Coach Fred here, and today I'm going to be going over a topic that has come up on the ACT a few times relating to expected value. And you may have learned this in your Algebra 2 class, but it's likely that you probably didn't. It usually comes in the probability section. And so here we've got, well, let's talk about what expected value is. It's really an expectation of what's going to happen, okay? It's the expected value that you can expect to get. And actually, to find expected value, you basically are going to take the sum of x times the probability of x, okay? So that's basically what you're looking for when you're looking for expected value. So it's actually not a hard concept. So here I give a probability distribution of the discrete random variable x, and it's shown in the table below. What's the expected value? And I gave a multiple choice question, which would be very similar to something on the ACT. All right, so the first thing I'm going to do is I'm going to multiply my random variable times the probability that variable will occur. So 0 times the 6th is going to give me 0. 1 times the 12th is going to give me 1/12. 2 times the 4th is going to give me a half. 3 times the 12th is going to give me 1/4. 4 times 1/12 is going to give me 1/3. And then 6 times a third is going to give me 2. Now I'm going to sum them all up. Quickly, though, because it's multiple choice, I can honestly cross out all of these values and know it's 3 1/6. Now, if you want to take the time and grab your calculator and you put them in your calculator, you're going to get 3.16 repeating, which works out to be 3 1/6. It's really no harder than that. But we could ask it in interesting ways. For example, the Cromwell Construction Company has the opportunity to enter into a contract to build a mountain road. The following table shows the probability distribution for the profit that could occur. Remember, it's an expectation if it takes the contract. Based on this information, the expected profit for the company if it takes the contract is. So we're filling in the blank. What is it? Okay. All right. So we're going to take our profit in this case and multiply it by our probability. So 30,000 times 0.15 gives me 4,500. 50,000 times 0.2 is going to give me 10,000, right? Because 5,000 would be 10%. All right, 70,000 times 0.3 is going to give me 21,000. And then 100,000 times 0.35 is going to give me 35,000. Okay, so I'm going to find the sum of those, and I'm going to do, so 4,500 plus 10,000 plus 21,000 plus 35,000 gives me 70,500. Again, expected value, you take the variable or the unknown or the item that we're talking about, multiply it by its probability, and then take the sum of all those values. Okay, so now we're going to look at a recent ACT problem directly from a test. This is question number 41, so in that medium to higher level questions, and you're going to have to, number one, determine if it's expected value, and sometimes they're going to ask you to actually do something more with expected value. So this one says we have a certain hotel has 80 rooms. Based on many previous years' occupancy rates, the owners of the hotel constructed the table below showing the daily occupancy rates and their probabilities of occurring for the coming season. Based on the probability distribution in the table to the nearest whole number, what is the expected number of rooms that will be occupied on any day during the coming summer season? Okay, so first of all, I know I'm looking for something expected, but they're actually asking me for the expected number of rooms. This expected value, if I find the sum, is going to give me the expected occupancy rate. So I'm actually going to have to do something with that expected value. All right, so the first thing I know is that I'm going to take my x and multiply it by the probability of x, like I did in the other examples. So 0.6 times 0.2 is going to give me 0.12. 0.7 times 0.4 is 0.28. 0.8 times 0.3 is 0.24, and 0.9 times 0.1 is 0.09. Okay, now I add all those up, and I get 0.73. So I know that my expected occupancy is 0.73 or 73%. But now they want me to relate it to the 80 rooms. They want to know how many rooms they can expect. So I just have to do one extra step. I take that 0.73 expected value, I multiply it by the 80, and I'm going to get 58.4. So in this case, my answer is going to be C. All right, hopefully that was helpful. We'll talk to you soon.